So before I start, let me introduce myself. My name is Somolo Cliff Oganda. I'm a student ambassador at Jomo Kenyatta University of Agriculture and Technology. So today I'll be your host for this session for today, where we're basically going to introduce what we all know is called infrastructure as code. And our main focus is going to be on the Azure cloud environment. So that will be the agenda of the day. And today I'm laying the foundation, or to bring an understanding to why do we need even code when it comes to provisioning of infrastructure. So this session is going to be interactive session because we basically trying to understand why would any organization or any developer or any DevOps engineer want to use code to provision his or her infrastructure on the cloud, to manage them, to tear them down, or even to use code to have a replica of the same environment a number of times. You can be in need of 10 environments supporting the same app. And all these environments, you want them to be identical to each other. So how is code going to play a major role while we do this? So everyone who has joined us today, feel most welcome to this event. And as part of our code of conduct, please be respectful to your fellow attendees. If you want to criticize respectfully and be respectful of each and everyone's opinion during this call. So in the midst of this meeting, if you have any question, feel free to interrupt me and ask any question that you will be willing to ask. So I will share my PowerPoint and you let me know if you can clearly see the PowerPoint I'm presenting. So as I've mentioned, this session will be interactive and we'll be having everyone in the call contributing in terms of sharing your experience, what you use on a daily basis, and how you think infrastructure as code can be helpful. So I've enabled the microphone for all attendees. So at any point you feel like you have any question, feel free to unmute and just raise your hand, then I'll give you that opportunity to unmute and then shoot your question. So can someone confirm to me that you can see the PowerPoint clearly from your end? Fantastic. Thank you all for confirming that. Now, as I've mentioned, this is going to be a long-running session, which means we'll be having these sessions every Wednesday from 8 to 9 for the next couple months. And this session will be focusing majorly on infrastructure as code on the Azure cloud environment. And as I've mentioned, I am Omolo Cliff Oganda, Better Milestone Student Ambassador at JKUAT. And as part of our community, we have a community called Kenya Data Platform User Group. If you registered earlier when I sent out the link, you were taken to a meetup page. And that meetup page was for Kenya Data Platform User Group. In that community, we talk about data, we talk about cloud environment, we talk about anything cloud, software development, web development, and also other languages like C#. So feel free to join the community using the link that was shared and be part of us because we have events happening every week, almost 3 events every week. So joining us, you'll be part of a very vibrant community that is focused to building one another and for us to build our technical skills together. Yes, so that's basically it. So Azure Infrastructure as Code. So before we even start, when I talk about Azure, I believe that everyone of us here understands what Azure is. Azure is basically a cloud service provider that is owned by Microsoft. Apart from Azure, we have other cloud providers such as Google Cloud Platform or the GCP. We have AWS. We have Amazon Web Services. We have DigitalOcean, Alibaba Cloud, and many more. But our focus on this series will be on Azure, which means all the tools that we are going to use in this session or the upcoming series will be Azure native tools. And we are going to understand and to see what are the tools that we have that we can use to help us implement any infrastructure in the cloud using code. So that is basically the agenda of the day. And let's see what we have. Now, we need to understand the fundamentals. And the first question is, what is infrastructure as code? Now, when we talk about infrastructure as code, this is basically the practice of managing and provisioning computing infrastructure like servers, networks, and storage using code instead of manual configuration, allowing for automated deployment and consistent environments across different stages of development by defining the desired state of infrastructure through text files that can be versioned, controlled, and easily replicated. Now, just as what I have in the slide, allow me to explain to you what it means in other words. So when we talk about infrastructure, we're basically talking about all the resources that you can always deploy in the cloud, which include servers, networks, storage. A good example, every time you build a web application could be a full stack application that has both the front end and has the back end, has database, and also has what we call the storage for your images. Now, if you want to deploy this application on Azure environment, then one of the things that you're going to do, you are going to log in to your portal, which is Azure portal, which assumes that you already have an account and a subscription on Azure. And then you're going to search for what we call maybe a static web app, search for what we call a web app itself or app service. You'll search for what we call a blob storage, and you'll search for what we call an SQL database or even Cosmos DB. All these components or these resources need to work together for you to have your web application up and running. Now, what I've mentioned Cosmos DB, I've mentioned as Azure Static Web App, I've mentioned App Service, I have mentioned a database and a blob storage. These are what we call infrastructure. And the normal way through which we provision these resources or manage them is usually by logging into the portal and then manually searching for what we want. And then now here, I'm talking about infrastructure as code, which means I'm no longer going to use the portal to manage my infrastructure or to provision them. Instead, I'm going to have a special text file that will have a configuration of all the resources that I want and all their capacities. So this special type of file will have a special kind of syntax that I'm going to use to define every resource that I want, the resource group, their capacities. For example, if I'm deploying a VM, I will define the resource group, I will define the location, I will define the capacity of that VM, the storage, the number of vCPUs. All these, instead of going to the portal, I'm going to use a special declaration of file, which can be versioned. Now, think of this file or code, which is in a file, as your normal source code. You boot up your VS Code, write your code, source code for your web application, and then using JIT, you upload your code to JIT, and then from JIT, you'll be able to version it. For example, if you add a new feature, you can have a new branch having a new feature. Also, you can make changes to your code every now and again, but you have a complete track record of the various versions of this code. Now, the same file that we have, or what we call the configuration file for our infrastructure, can also be versioned, just like you can version your source code. So we are going to see, why do we even need this code in the first place? And why do we have to bring in the idea of versioning this file that is used to provision our resources? So let's continue and get to see what we have. Now, one question that you can be asking yourself is infrastructure as code same as DevOps? Now, you need to understand and get the difference that we have here between infrastructure and DevOps. Now, ISC is a short form for infrastructure as code. So I'll be using ISC moving forward. So every time I mention ISC, I'm simply referring to infrastructure as code. Now, ISC is a key DevOps practice and a component of continuous delivery. With ISC, DevOps teams can work together with a unified set of practice and tools to deliver applications on their supporting infrastructure rapidly and reliably at scale. Now, when we are trying to say here that IAC is a key DevOps practice. Now, when I talk about having a special configuration file where I define everything that I have, and we talk of DevOps. Now, when we talk of DevOps, we're basically having both developers and operations engineers coming together to help ship our code smoothly to our environments, could be testing environment, staging, or even production environment. Now, why do we even link IAC to DevOps? Because with IAC, it gives you that flexibility to be able to automate your cloud infrastructure or your application infrastructure, which means I can be able to boot them up real quick just using the file, or even tear them down with a single command. And that is why we are trying to streamline the process through which the DevOps team can easily provision the infrastructure that they need to the cloud just using this code. So in many instances, you'll find that those who understand ISC so well, they can easily become DevOps engineers because they understand how to version your cloud environment and how to even have several replicas of the same environment for different stages of your application, staging area, testing area, and production area. In some instances, we even have user testing area, or we can also have operation acceptance area. So infrastructure as code and DevOps are kind of, in a way, share common similarities. Now, how did we even come to IAC over traditional methods? You know very well, one of the key characteristics of a cloud environment, be it Azure, be it GCP, be it AWS, is elasticity and self-service. So when I talk about elasticity and self-service, first things, let's talk about elasticity. Elasticity is the characteristic of cloud environments to be able to scale out or up or scale in or down based on the system requirements or the performance that you need for your application. To give you a real example is, let's take an example, this Uber application. During the morning hours and evening hours, there's more traffic and more demand for Uber rides, okay? And therefore, the Uber team knows very well that in the morning, they need to have more infrastructure. If they're using computes, they need to have more computes or virtual machines provision to support the rise in demand or the traffic that is now stressing their infrastructure. They need to expand automatically. During the afternoon, there's a drastic drop in demand for Uber rides, and therefore they need a way of doing away with the extra computes that were added in the morning. And the same happens in the evening when there's high demand, when now people are going back to their homes from their workplaces. Now, the ability to increase these resources or even to reduce them based on the traffic or demand is what we refer to as elasticity. And also self-service, because all these cloud services providers, they allow you to manage your own cloud infrastructure on your own. If you have access to the portal and you have a subscription, you are in a position to manage everything on your own. You decide when you want to add a resource and when you want to remove a resource, and you decide when you want to change its capacity. So through this, there was now that opportunity to bring in what we call IAC to help in automating all this that we are doing manually on the cloud. Now, you see, creating a discarding infrastructure on demand in hours or minutes, especially in test environments, can only be made possible when you have a tool that allows you to automate all that you wanted to do on the cloud. And then also, if you just go to the portal and then provision the resources, you can't keep track of your initial state of the cloud environment and the current state. But imagine a scenario when now you have a file that has a clear outline of all your cloud infrastructure, you can be able to track it. And remember, I mentioned earlier that this file can be versioned. So we can have the first version, second version, and third version. So based on the demands, we can be able to just turn it off, tear it down, or even revert back to the previous version that we had earlier. And also going forward, there's the need for developers to also have access to the production environment. And in this case, we won't want to give just developers access to the actual environment, but instead, we want to give them a documentation of what we have in the cloud. Documentation is what we'll be having as code. Now, what are some of the benefits of ISC automation? ISC eliminates the need for manual configuration using code to define infrastructure settings, enabling automated provisions and deployment. Using code, you can automatically provision and even shut them down once you no longer need them. Remember a case where you are in an app development and every day you want to have a test environment. Test environment should be teared down in the evening when we have no more work going on. And imagine a scenario where you have to provision this test environment every day using the portal, but with ISC, you will need the file, and within 5 minutes or even 2 minutes, you will have the entire cloud environment ready for you to test. Then consistency. By using code, ISC ensures that infrastructure is consistently set up across different environments, like development, staging, and production. Now, why do we need consistency? If I'm building an application that is supposed to support 200 users, and I test it in an environment, let's say a test environment that has the capacity to support 200 users, I should have the same capacity on the production environment so that I am sure that this application on a production environment is able to support this number of users. Now, with consistency, which means we don't want to have different capacities in the test and in the production. If I have 20 in the test, I should be having 20 VMs also in the production to be sure that my application is going to behave in a similar manner as it behaved in the test environment. So there's that need for consistency. Then version control. Infrastructure as code is stored in a version control system like Git, allowing for tracking of changes, rollbacks, and collaborations. That is self-explanatory. You can version your IAC code so that you know that you can roll back to previous version when the new version isn't working consistently or as you expect. Or if you have new deployments, you can just add them on top of that configuration file. And the next time you deploy, we'll have the new cloud environment with the updated infrastructure. Then integration. ISC is particularly well suited for cloud computing platforms where resources can be provisioned and managed through APIs. As you all know, these cloud environments like Azure, they allow you to manage this resources through APIs. Basically, everything you do, even in the portal, are done through APIs, HTTP APIs. Be it on PowerShell, be it on Azure CLI, they all consume HTTP APIs or REST APIs to help in managing these resources. Also, there's a need to understand how IAC has evolved and how to avoid manual configuration to enforce consistency. Now, I mentioned earlier that we need to understand why do we even need IAC in the first place? One of the main reasons why we need IAC is what we call configuration drift. Now, a minute, I expand on my window. Yes, so we need to understand, like IAC, it evolved to solve the problem of environmental drift in release pipelines. Now, without IAC, teams must maintain deployment environment settings individually. Over time, each environment becomes a snowflake, a unique configuration that can't be reproduced automatically. With this, it becomes inconsistent, and inconsistency among environments can cause deployment issues. Infrastructure administration and maintenance involve manual processes that are error-prone and hard to track. Now, let me show you visually what happens with configuration drift. I'll skip to my slide here. Now, if you look at this slide has some what we call configuration here. Look, so we have this. In this slide, let me just go back really quick. You see, I have a test environment and also I have production environment. In test environment, you see I had 2 cores and 4 GB RAM, another 2 core, 4 GB RAM. So I have 2 VMs on my test environment where each VM has 2 cores and a RAM of 4 GB. But if you go look at the production environment, I have 2 VMs still, but there's a slight difference in terms of the capacities or the definitions of the storage that we need. Look, we have 2 cores for each VM, but in production, one VM has 2 cores and the other one has 4 cores. Also, the RAM is different because in test environment, we had 4 GB of RAM, but in production now, we have how many GB of RAM? 8 GB of RAM. This will cause a problem. Why? Because in our test environment, we had our application working so well. Let's say application was intended to support only 200 users. And we realized that only having 2 VMs, each of 2 cores and 4 GB of RAM, was enough for us to run that smoothly. But in production, we now have 2 cores, 4 cores, and 8 GB of RAM each. What is the problem here? The problem is our application will work well in this case because we've in fact added more capacity to what we had. But on the other hand, we'll have more cost incurred to us because this is more than what we need. Usually, we need the same environment in our test to be the same environment that we have in production to be sure that our application is going to behave consistently in both environments, test and production. So in other words, using this slide here and this image here, configuration drift is the difference that you have in between your one environment and another environment, and it will cause your application to behave inconsistently. So let's understand, what is configuration drift? This is the difference between environments, such as between test and production, like I have mentioned. A difference such as 2 VMs that should be configured exactly the same and host 2 instances of the same app. Like we have here 2 VMs, but they have different configurations in production and in the test. It is as a result of unexpected, incomplete, or incorrectly executed changes. Now, why would we even, under what scenarios or situations will we be having such things like configuration drift? When we manually manage our infrastructure by going to the portal or using the Azure CLI or using the PowerShell or the inbuilt CLI. But in a case where we have a specific configuration file that has the code that outlines our infrastructure, just like your source code, when compiled, will always have the same binary output. The code for infrastructure will always produce the same environment that aligns to what you define in your code or the specific file that you're going to use to define that code. So that is why, by avoiding manual configuration, we are also avoiding this problem that we are calling configuration drift. Up to that point, do you have any question from anyone? Up to that point, is there any question from anyone? There being no any question, let's continue. So let's understand some of the tools that help us to be able to use code to define our infrastructure. We have ISC tools. So one of them, we have Bicep, we have ARM templates, we have Terraform, we have Puppet, we have Chef, and we have Ansible. All these tools brought together, they can help us to manage our infrastructure consistently and efficiently. And what I have here is what we call the Bicep. The image you're seeing here, or the icon you're seeing here, is Bicep. Now, Bicep and ARM templates, these are Azure native tools, which means going forward, we are going to focus on Bicep and ARM templates. So these are the tools. This can be used on other platforms. For example, Terraform is cross-platform. You can use it on Windows, on AWS, you can use it on Azure, you can use it on GCP, or you can use it to manage all environments across. So that is, we're going to see how to focus on ARM templates and Bicep. Now, before we move forward to actually starting exploring these tools, we need to understand how the cloud infrastructure is. Now, I earlier mentioned that the infrastructure refers to all resources which you can use as part of your solution architecture. Now, this being one of them, we have virtual machines, storage machines, virtual networks, and databases. And then besides this, I have a very good diagram here that tries to outline the infrastructure in the cloud. And I want you to see what we have here. On top here, we have Azure DevOps projects. And then we also have Visual Studio Code environment. And then we have a user application that is right there. If you also check on the left side where we have Azure DevOps projects, you see there we have something like a JSON, and then you also have Git version control and DevOps itself. And all these are pointing to the cloud infrastructure. Now, we have the application here, and we have the tools that you're going to use to deploy our application. And then on the cloud level, we have the actual resources. You see, we have SQL, we have storage, we have VM, we have a resource group, we have subscription. Now, when we have our application, we have the tools, we are able, using the IAC, to deploy all this, both the application and the infrastructure, at once to the cloud. So basically, the cloud, we have the resources, and then using the resources, we can contain our applications, and using the tools that we have, we can manage both the resources and our applications. Now, before moving further, we need to understand how does communication takes place on a cloud environment. So in a cloud environment, we have two planes. We have control plane and we have data plane. And we need to understand what's the difference between control plane and data plane. As you can see here, control plane is on top, and then we have data plane, which is just below the control plane. Let me explain that in details in the next slide. Now, the control plane is responsible for management operations that control resources in your environment. So what are some of the features of control plane? It handles resource provisioning and configuration, and even the management. It is used to create, update, delete resources from your cloud. It's also used to lower throughput, higher latency, which means latency and throughput are always measured in terms of seconds and minutes. And then we have examples like Azure Portal, Azure CLI, ARM templates, Azure PowerShell. So this line alone is enough to define to you what control plane is. Control plane is basically that interface that allows you to provision resources on your cloud environment, because through Azure Portal, you can do that. Through Azure CLI, you can do that. Through ARM templates, you can do that. And also through Azure PowerShell, you can do that. So usually in control plane, you are authenticated using an Azure Active Directory. And what are some of the operations that are included in the control plane? Number one, you can create a storage account, set up network rules, configure replication settings, modify access policies, and also deploy resources via templates. That is it for the control plane. Now, let's look at data plane. The data plane handles the actual workload operations and data accessed within provisioned resources. Now, the control plane gave you access to provision the resources that you needed, but now data plane now gives you the ability to control the workload operations and to access data from the resources that you already created through the control plane. And now, what are some of the characteristics of data plane? Manage actual data operations and workloads. High throughput and low latency usually happens in milliseconds. Remember, control plane, when provisioning resources, you can wait for resources to take like 3 minutes, 2 minutes for it to provision. But in data plane, this takes milliseconds. High throughput, low latency. It's used for reading, writing, and processing data. Examples include writing into a blob storage, querying a database, sending a message to a queue, and many more. It often uses resource-specific authentication, such as connection strings, SAS tokens, For example, if you ever worked with Cosmos DB or even Azure Blob Storage, you need something like connection string or resource token to authenticate your application to this resource. Now, what are some of the operations that are included in the data plane? One of them includes uploading a file to a storage, reading data from a database, processing messages in a queue, executing a function, and also retrieving secrets from a key vault. In a nutshell, what happens? Control plane allows you to choose what you want to use in terms of infrastructure and resources, VMs, storage, and databases. Data plane now control how data flows or managing data access in these resources. That's why it has to be having high throughput and low latency, usually within milliseconds. And some of the things that you do, we just mentioned, uploading files, reading data from a database, retrieving secrets from a key vault, and many more. Now, what are some of the differences between data plane and control plane in a more layered format? So we see here that when we talk about data plane and their primary processes, control plane is for resource management and configuration. Data plane is the actual data operations and workloads. In terms of operations, control plane creates, updates, and deletes resources, whereas data plane reads, writes, and processes data. Examples of control plane, we have Azure Portal, ARM templates, and Azure CLI. Data plane, we have uploading of files, querying databases, and sending messages. And also we have what we call authentication. In data plane, we authenticate using what we call the Azure Active Directory, which means it's always at the root level, or sometimes at the subscription level. But for the data plane, we authenticate using things like connection strings, SAS tokens, and even keys. So data plane may be affected by management services outages, but data plane generally is more resilient to outages. And also data plane, control plane helps you manage APIs, while data allows you to manage data APIs. So if you look at what we have there, we have limited API throttling for control plane, and also we have, for data plane, we have scales with the resource capacities. Yeah. And in terms of tools, for control plane, we have Azure Portal, Terraform, and PowerShell. And for data plane, we have SDKs, client libraries, direct APIs. Now, this can take you back to what we did last week in the Data platform. We were learning something on Cosmos DB. And you saw that our host for the day was Dennis. He installed an SDK for Cosmos. So that was more of working with the data plane. And when he went to the portal and provisioned the Cosmos DB, it was more on the control plane. So that is important for you to understand when we are going to work with the ISC or using code to manage our infrastructure. Now, moving forward, I want us to see how communication itself happens when on a cloud environment. You know, when you go to the cloud, there's a level of communication that happens. Now, on top, we have the user, who is you, logging into your portal and trying to access resources or even just provision any resource. And this can be done through the portal, the CLI, the PowerShell, or even using SDKs or ARM templates, okay? And then now we have the actual which is the Azure Resource Manager. Now, every time you communicate or you do anything in the portal using either of the above interfaces, every request that you make on the portal or on your subscription has to go through Azure Resource Manager. Now, what is Azure Resource Manager? This is the service that helps manage all the activities happening on your environment. Creation, deletion, and also routing that request to specific provider on the Azure portal. Now, I'm the user right on top here, and I'm using either Azure CLI, PowerShell, or even the portal. If I send a request, for example, to create a VM or to create a storage account, it has to go through the Azure Resource Manager. Now, what happens in the ARM here? Here, it authenticates. Do you have the subscription that allows you to perform that activity? For example, create a storage account. Do you have the role or the permission to do so, remember we have roles and permissions on cloud environment, or what we call the identity and access management. So in the ARM or the Azure Source Manager, here's where all these checks has to be performed before you are authenticated and allowed to communicate with that service that is responsible for that resource that you want. Now, coming down, you also see that we have resource provider. Now, I want you to understand that every time you create any resource on the cloud, there's always a specific service responsible for that. We have computes, we have storages, we also have network. If you try and create any resource at the moment, you will see that if you are trying to create a VM, it's always on Azure.compute. If you're trying to create a virtual network, it's always on Azure.network. If you're trying to create a storage, for example, you'll realize that your URL has a segment that says Azure.storage. So ARM templates, think of it like routing this request to the specific services responsible for giving you that resource that you want. If you want a VM, then ARM of the Azure Resource Manager will route that request to the Azure.compute service that will in turn give you the ability to provision that virtual machine. So you need to understand this. It doesn't matter whether you are trying to do this via the CLI, PowerShell, or even an SDK. All requests have to go through the Azure Resource Manager. I hope that is clear. Now, I mentioned that everything has to go through Azure Resource Manager. And then we need to understand, why do we even need Azure Resource Manager, and why do we have ARM templates? Everyone who is in attendance at the moment in this meeting, if you have ever created any resource on Azure using the portal, on the last step, there's always a prompt just below the screen that asks you, do you want to download this template to help you provision other resources in the future? Just by reaction, has anyone seen such kind of a button, download this template? Just react so that I can be sure that we're on the same page. Once you provision everything, before you click on create, there's always a button saying, download this template. Just react, fantastic. So we're on the same page. Now, that is what we call the Azure Resource Manager template. And you'll always have the ability to preview how it looks. You will see everything defined in code. And if you download this template, these templates can be used to provision other resources, the same resource in your next deployment. Now, what is ARM templates or Azure Resource Manager templates? This is a service for working with ISC. All Azure infrastructure management is done using the ARM templates. This means if you're using Bicep, if you use Terraform, or any tool that you are going to use to manage your infrastructure, everything under the hood will be transpiled into ARM templates, because that is the language that Azure understands. Now, the ARM templates, they have a RESTful HTTP API that you call to list, create, update, and even delete all resources on your Azure account. Now, PowerShell, Azure CLI, the portal, also the inbuilt CLI on Azure portal, they all under the hood use what we call the ARM, or the Azure Resource Manager. Now, this ARM is the execution engine of ISC, because everything last step will be transformed or transpiled into what we call the Azure Resource Manager templates. And we're going to see how an ARM looks like in real life. Now, moving forward, let's now look at it again. What happens here? Now, here is like my interface that I'm using to manage my infrastructure. So I have Azure portal. I'm on Azure portal. Then it's on PowerShell. Someone else is using Azure CLI because you are more accustomed to commands. And some are even using SDKs or REST clients. All these are what you can be used. In other words, these are SDKs that you use to access the cloud. And you can see even the SDKs have to communicate through Resource Manager. And what happens in the ARM here? What happens here is the authentication. Remember I mentioned we have to verify, are you an owner for this subscription? Are you permitted? What role do you have? Do you have the rights to read and write? So all that authentication happens here on this level where we have Azure Resource Manager. And if yes, then you're allowed to manage data, provision a web app, create virtual machines, and also manage other services. So that's the infrastructure or the structure of how communication happens. Every time you make a request to Azure Cloud, this is the flow of that request. So ARM will route everything. Now, let's look at an example of what we call an ARM template. So an ARM template, like I said, our focus on this series is on infrastructure as code. And that is why we are not seeing any portal here. What we have here is basically a code which is written in JSON format that is used to define what we need to have, or what we call the child state in our cloud environment. So you see it's in form of JSON, key value pairs, and because we also have nested values here. Now, I want you to look at this on the high level. Don't try to understand what you have here. At the moment, I just want you to look at it from the high level perspective. Just looking what we have. For example, we have the schema here. So we have schema for the ARM templates. You can see we have the schema, and then we have its value. We have the version, and we have the parameters. So parameters, these are basically values that we're going to use in the following declarations, the declarations that are going to follow. And then we have now what we are trying to provision. Look, we have storage account, the type, standard, everything. I mean, look at the values here. I don't want to complicate this at the moment. So we have parameter for the storage account name, the account type, and the location. And then we now have the resource. The resource is the actual infrastructure that we are now trying to deploy here. Now we have the type. Now you see what happens here. We have Microsoft.storage stroke storage accounts. So we are trying to provision a storage account. And then the name. You see the name does what? The name tries to refer to the parameters that we have here on top. And we are referring to the new storage account name, which is what we have here. And then we have the API version. You have to provide that. The location is also referenced from the parameters. See here, we have the location that was defined here. So we simply call the name of the parameter down here. Now, all your ARM templates will be in this format in terms of JSON. So the more we move, we're going to write all this from scratch, and we're going to understand everything and what they mean. For now, I want you to only look at the structure, we have parameters, and then we have the resource, and how in the resource, we are trying to refer back to the parameters that we have earlier in that declaration. And now let's look at the structure. Now you see the schema defines the ARM template version. Then we have the content version, which is your template version number. Remember, we can always version our templates. Parameters are user inputs. For example, we're trying to define the storage account name and location. And then the resource is what we're trying to create, a storage account. Then we define the type, the API version, the name, the location, which will be taken from the parameters, the name from the parameters, and then SKU, you also define it there, the kind of the storage account that we want, like the version, storage version 2, the properties, for example, the access tier and the security settings. Is it hot or cool tier? And then we have the outputs. Now the values that are returned to you after the deployment, such as the storage account ID. So that is the overall structure through which ARM template is defined. Now let's move forward and look at another tool, which is the Bicep. Now Bicep is now what we call a DSL, or a domain-specific language for Azure. Now, ARM templates are kind of complicated and they have limitations. One limitation is it's hard to define conditions. Number two, it's hard to define loops. It's really complicated. It's doable, but complicated. Now we have Bicep. Bicep is different from ARM templates. Let me explain what happens. Bicep is declarative. ARM templates is imperative. What's the difference? In ARM templates, if I want a storage account, I have to tell it the step-by-step process that it has to go through to give me a storage account, okay? But in Bicep, which is declarative, I only need to tell it what I want, or the desired end state, okay? It's like to say, if I want to make, or if I want to eat a chicken, I have to know that I need to buy the ingredients. I need to buy the chicken itself. I need to prepare it this way, boil water, do this after 5 minutes, steam it for this time. But if I'm to use bicep, which is declarative, I simply say, I want to eat and I want chicken. So what I get on my end is the chicken itself. I don't care the process that I have to go through to get this chicken. I simply tell you, I want chicken, that's what I get. I want storage accounts, that's what I get. In ARM templates, I have to define all this process, which even makes it error-prone, complex, and even time-consuming. But still, even with Bicep, which is a DSL or the domain-specific language for Azure, after defining it using that simple structure, all that Bicep code will still be transpiled to ARM templates. Remember I said ARM is the layer between the actual thing that we want and interaction that you're having here. We have to verify everything. So even after writing your Bicep code or file, it will be transformed into an ARM template. But now that is now the work of Azure itself. For you, tell us what you want. Tell us the desired state, not how to get what you want. Just tell us, I want a VM 2 GPUs or 2 vCPUs. I want a storage account and I want a blob storage. That's all you need to tell us. But with ARM templates, I need to say, okay, go to Azure Compute, find me this, provision it, the account type is this, so and so. No. That's why we have now Bicep, which is the most modern adoption when working with ILC on Azure. You need to know that ARM templates and Bicep are Azure native, which means you can only use them on Azure. We have other tools that you can use on other platforms like Terraform, Jeff, Ansible, and the rest. In our sessions, we'll be focusing on Bicep and ARM templates. Now, what is Bicep itself? Now, Bicep is a declarative language for deploying Azure resources. It has a simplified syntax compared to ARM templates. It simply has JSON. Also, it's native integration, which means it's built inside the Azure platform itself. And also its modular approach for usability and maintainable code. Maintainable code is called that easy to read and write. So that's what Bicep is trying to give you, ability to read Bicep file easily and also to write it effortlessly. Now, moving forward, what are the key benefits of Bicep over ARM templates? We have improved readability and maintainability, type safety, and intelligence support. So intelligence support, when working with Bicep, we have an extension on VS Code called Bicep. So Bicep, when running any Bicep code on VS Code, you will get syntax highlighting, you'll be able to format it, because remember, when working with ARM templates and Bicep, things like indentation and spacing really matter a lot. You don't just go around having extra spacing and everything. Now with Bicep, you get out of the box support on VS Code when you install the extension called Bicep. Now, also it has reduced complexity, like you can use JSON templates. Now, Bicep has no state management required, unlike Terraform. Now, those are benefits for using Bicep over ARM templates. And then let's look at an example of a Bicep file. I want you to compare it with what we have for ARM templates. Now, this is a Bicep file for provisioning a storage account. How many lines of code do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9 lines of code to get a storage account. But if you go back to the ARM templates, how many lines of code do we have? We have close to 30 lines of code. Now, even if it were you, between ARM templates and Bicep, which one will you use? Let me answer for you. I will use Bicep because I only need 9 lines of code to get all this here. Now, once this Bicep is compiled, under the hood, what you'll be having is exactly what we have here. And that marks the end of our today's session, which was to lay the foundation of what to expect in the upcoming sessions, where we'll now go hands-on skills, doing the actual things, how to manage them, to provision them, the best practice of writing a configuration file, and we're going to go deep into these tools, Bicep and ARM templates. So, any question up to this point? Any question? Or any clarification or anything you want to add on top of what we've discussed? Yes, Kelvin. Just unmute and ask.
Okay, hello guys. So my question is about Azure. According to me, I'm not that good in dealing with Azure, so I just wanted to ask, like, can you please share the roadmap to the roadmap to learning Azure?
Yes, we can actually answer that. So Kelvin is saying, is it Kelvin? Yeah, Kelvin Karaoke is saying that he's actually new to Azure, and now he wants the roadmap to get started with Azure. Now, this is going to be straightforward. Now, to start or get started on Azure, you need to first get the fundamentals right. Now, to get the fundamentals right, you need to have an account on Microsoft Learn, which has a learning path, which in turn have modules which you can take step by step, taking you from the very beginning or the very scratch as you advance to more concepts. So when you take the fundamentals path, you will get to understand what is cloud computing, what are the benefits of cloud computing, the characteristics of cloud computing, security practices on cloud environment. Yeah, basically the basics that you need to get right before you get into any other concept in the cloud. So the best platform that you need to learn from is the Microsoft Learn platform. So all you need is to create an account. Once you create an account, you will have access to learning path and learning modules. Also, as a student, you can have access to a subscription on Azure using your school details. It will give you free resources and $200 credit. I'm not sure it's $200 or $100 credit that can help you in practicing, keeping into practice what you've learned. So that is where you can start from. And then from there, you'll just find yourself moving on smoothly. First things first, get the fundamentals right, after which you'll be good to go. I'm not sure if that answers your question.
It answers partially. So,
I
okay,
mean, we have Kevin.
okay.
Kevin can help us. Yeah. Kevin Gatimu, please unmute.
So,
You're having an echo, Kevin. Hello, Kevin.
yes. Okay. It's not a question. I just realized that the chat is not enabled, so people can't ask question. I also wanted to share some links on the chat, so sharing them through the QA section.
Sorry, I didn't realize that. Sorry, guys.
But on the
Yeah.
QA section, I have shared a couple of links. For example, there was someone who was asking about how to get started with Azure. So in our user group, we have some community calls which some of our members have gone ahead to prepare, and we have hosted them for almost 7 or 10 sessions or something like that. So I'm just sharing it in the QA section. So if you're interested in learning Azure on a slow pace via our community course, you can just see that playlist there. It explains from scratch what cloud computing is all the way to Azure and other things there. It's in the QA section. Thank you.
Yeah, thank you so much, Kevin. Gatimu. So, Karaoke, are you now good? Does that answer your question?
Yes, yes. But I have a query directed to the other Kevin. Okay,
Yes.
my QA section is not okay. It has worked. But thanks for the tip. It was helpful.
Okay. Now We have Geoffrey Kirumba. You have a question? Unmute and ask. Or Geoffrey, you have a question? Geoffrey,
am I audible?
Yes, you are.
Oh, so hi guys. My question was on the arm template. Between the arm template and the bicep, you have explained that there are blueprints that are used to control the arm engine, that is the Azure Resource Manager. So my question is, bicep being more readable, does it present any difference in performance as compared to the ARM template?
Okay, let me answer that. Mute. Okay, so I'll answer that. So ARM templates and bicep, all these two tools, they actually accomplish the same task. The difference is in terms of readability and the ease by which you can define your infrastructure. But there is no one that performs better than the other. What happens, in fact, if you have the ability or you have the time to write an ARM template, the better you are, because the Azure want to go another extra step to compile your bicep to ARM templates. Because by default, even if you write define your infrastructure using bicep, it has to be transpiled to ARM template, which is what we are seeing that has all those many lines of code. Now, if you have that capability or the time or the mastery to write the entire ARM template, you're good. But bicep will make it easy for me who didn't write that code to be able to read it with ease. Also for you, look at that. Minimizing a code from 35 lines to 9 lines of code. Which one will you go for? In terms of performance, they all do the same thing because under the hood, we're going to have ARM templates as the final product, which will be used to manage your resources. So, Geoffrey, does that answer your question? Geoffrey? Yes, also on the chat, we have a summary that has been posted. Yeah, so any other question from anybody? There being another question, any announcement from our MVPs and ambassadors in the meeting before we end the call? Okay. Seems there's no announcement. So thank you all for making this event possible. You've made it a success, and I thank you for that. And so just to make it clear, this series for Azure Infrastructure as Code will be happening every Wednesday from 8 p.m. to 9 p.m. So be sure to join us next Wednesday as we get more practicals, because today we've just laid the foundation. So from Wednesday, we're getting into the actual thing. We're going to see how to write biceps, how to set up our VS Code environment, how to have an application that we can deploy together with the infrastructure as code, and a lot more that is to come. So be sure to join us on Wednesday every week from 8 to 9 for this session. So thank you all for coming, and have a good night. The recording will be shared once it's ready. And for the links that will be shared on the chat. Oh, sure. We have, yes, Dennis, please just unmute.
Yes, Omolo. Thank you for today's session. I hope I'm audible.
Yes, you are audible.
Yeah, so it's just to remind our that the days like we shifted now from TypeScript on one series. We shifted it from Wednesday to Saturday so that we can accommodate you on Wednesdays. So on Saturday.
Hello.
Yeah,
I was having trouble. Like, hello.
Someone. Yeah.
I'm sorry. I'm asking it now. So, do you guys have like the best resources to like do bicep? Because I'm currently in a role that actually does that, and unfortunately, Microsoft documentation is the worst I've seen. And I'm doing a lot of bicep. Haven't done a lot Terraform here because that's what I was special about. But yeah, do you have like best resources to learn bicep?
Yeah, I have a book which I can share with you after this call. So be sure to text me after the call.
Okay, text you where specific?
On this chat. Hello?
Text you where specific. Do you have maybe Twitter, LinkedIn?
Oh, sure. Let me share my LinkedIn account on the chat. In the meantime, so that we can connect, okay?
Okay, better.
Oh, sure. Yes, Dennis, please go ahead.
Yeah, so I was saying TypeScript on one series is still continuing. We shifted it from Wednesdays to Saturday. So this coming Saturday will be more of working with backend development, which is now building a TypeScript Express API with Cosmos DB. And I'm sharing the meetup link for you to schedule or to RSVP your spot for coming Saturday. So make sure to RSVP there so that you can get the meeting link for Saturday's session. So that's what I had to say for now.
Okay, thank you so much, Dennis. I've shared my LinkedIn profile on the chat. You can check it out so we can connect. So any other concern or question from anyone? Okay, so there being any other question, thank you all for coming and have a good night. Yeah, you can leave at your pleasure.
Najaribu log out of this thing. Imekataa. This is the worst thing ever, man.